Hey, Physical Science with Stremecki here from North Iredell High School. That's right. Alright, today what we're going to do, this is for Module 11, Part 1. We're doing our first calculations together of acceleration. Okay? Now, I know it's kind of a big formula right there, but we're not going to let that sweat us, right? Just like in the instruction video, it's no big deal. The important part is just to plug the right numbers in the right place, and it's just a little bit of math after that. Alright, so here we go. We got a runner is traveling at 2.5 meters per second and is nearing the finish line. He suddenly accelerates to a new speed of 3.7 meters per second in only 3 seconds. What's the acceleration of the runner? Now draw a picture of the problem. Sometimes it really helps. Sometimes we get a bunch of numbers up here. It can get a little confusing as to where those numbers go in the formula. And having a picture can help. So I'm going to draw somebody right here. You know, they're getting ready to run a little bit. And the runner's traveling at 2.5 meters per second right there. And then 3 seconds later, according to the problem, they're up to 3.7 meters per second. So now they are trucking pretty good. Okay, and they're up to 3.7 meters per second. Now, if it doesn't help you to draw the picture, then you don't have to, but 90% of everybody else, we really need to draw the picture. Okay, it helps us to visualize. So, questions are, which VI, or that little VI, that stands for initial, which velocity did my runner start with? 2.5, right? Started here, ended there. So it started with 2.5. What's the final velocity? That's the one we ended with right there, 3.7. And how much time did it take? It took a big whopping 3 seconds. And the acceleration, what is the acceleration? That's what they're asking us to find. So I'm going to put a question mark right there. Now, first step, I started doing some of these for you, is we write down the formula. For some reason my equal sign came out to look like a minus sign. So A is equal to VF minus VI divided by T. So A is equal to, we need the VF right there. VF goes right there. So the VF is 3.7 minus the initial, which is 2.5. Then we're going to divide that by the T down here, which is 3. Let's simplify that. A is equal to, what is 3.7 minus 2.5? Let's get that out. 3.7 minus 2.5, and we get a whopping 1.2. So 1.2, and down here we still got 3 seconds. So to calculate the acceleration, you take 1.2 divided by 3. So 1.2 divided by 3, and we get 0.4. So 0.4, and if you remember back from the instruction video, the units for acceleration is always meters per second, or you can say meters per second squared. Alright, that was pretty easy. Number 2 is the exact same way. They give you initial and a final velocity and some time. Number 3 is the same way. They give you a rabbit is hopping along at 0.55 meters per second. Sees a hawk flying above, and now in 2.2 seconds, it's up to 36 meters per second. That thing is really cranking. What's the acceleration of the rabbit? Okay, so it's done exactly the same way. I'll do this one with you as well. This looks like fun. So my rabbit, good Lord, I shouldn't have done this one because I have no idea how to draw a rabbit. Oh, look at that. I'm going to stay right there. That looks almost like a rabbit. So right here it's going 0.55 meters per second. And then when it sees that hawk, lickety split, man, that rabbit is cruising now. Right? It is major cruising along. I have no idea how to draw this. There's the rabbit. Maybe the paw's going out front. There's the face. Yeah, there's my jet-propelled little rabbit there. Now it's going 36 meters per second. Your drawing probably looks a lot better than mine. And it took a big whopping 2.2 seconds. Alright, so let's plug in our numbers. The initial velocity is what we started with. That was 0.55. The final velocity, my rabbit got up to 36 meters per second. The time it took was 2.2 seconds. And we're looking for the acceleration. So we're going to be plugging in these numbers. So A is equal to, final velocity goes here, which is not 5.5. Final is the last one you ended with. So 36 minus the initial, what we start with, 0.55. And the time goes down here, which is 2.2. So A is going to be equal to, first we'll take the 36 minus the 0.55. We get 35.45. So 35.45. And we still got to take care of that 0.2 down there. So now, take 35.45, which is right there, divide that by 2.2. And we get 16.1. So 16.1. And we're going to do, remember acceleration, it's got the units of meters per second per second. Okay, so we did the first three together. Let's see what the backside looks like here. Number 4. Let's see, we got an initial velocity, final velocity, and time. Initial velocity, final velocity, and time for number 5. Number 6, we got initial velocity, final velocity, and time. So these are all exactly the same. Hopefully you'll have a pretty easy time doing these. Number 7, same thing, initial velocity, final velocity, and time. Number 8, initial velocity, final velocity, and time. Same thing again. Number 9, initial velocity, final velocity, and the time again. So these are all first 9 questions exactly done the same way. Okay? So let's take a look here. Now, number 10, things change around a little bit. So I want to do that one with you. But 1 through 9 is done exactly the same way. Initial, or the final velocity minus initial velocity, then divide by time. Now this one, we've got a boat. Okay. Excuse me. And the boat can accelerate. Now this thing's already got the acceleration, 3.4 meters per second squared. So the acceleration is given on this one. So math-wise, this one's going to be a little more challenging. Bert's boat can accelerate from 3.4 meters per second squared when the water is smooth. First thing in the morning. How much time would it take for Bert to go from 4.5 meters per second all the way up to 22.5 meters per second? So he's going to speed up. So the initial velocity is 4.5, final velocity is 22.5, and the time is what we're looking for. So let's tell you how to do this problem. So write down the formula first. A is equal to VF minus VI divided by T. Now, what goes on this side is the A, which is 3.4. Like that. The final velocity, which is 22.5, goes right there. The initial velocity goes after that, which is 4.5. And T goes down below, which we don't know. So we're just going to leave T there. Well, let's simplify this thing a little bit. So let's leave the 3.4 right there. We'll leave the t down there. We're going to do 22.5 minus 4.5. Let's get that part done. 22.5 minus 4.5 is 18. So that's 18. Now, hopefully this is starting to look a little bit familiar. Remember, we're looking for something in the denominator. In the denominator, what we have to do cross, multiply, divide. So we're going to put that over 1. Now we're going to cross up. T crossing over times 3.4 is going to be 3.4 t is equal to, now you cross this way, 1 times 18 is 18. Now the divide part. You got that 3.4 next to that t. To get rid of it, you got to divide by 3.4. Both sides. That way the 3.4's cancel out. Leaves you with t all by itself. So the answer is going to be, as soon as we take 18 divided by 3.4, and we get 5, I'm going to round up, say 5.3. 5.3, and then we talk about time. And look back up here in our problem. Oh, I see seconds squared, so it must come in seconds, not hours or minutes or anything. Okay? Number 11 is done the same way. Let's take a look at number 12. Yep, how much time does it take? So number 12 is going to be done the exact same way. Sorry about that. And number 13, how much time does it take? So exactly the same thing with number 13. Okay, well, you've got some good help on this. We did 1, 2, 3 of these problems together out of 13. So you've got some good startup. You know how to do these, and I'm here to help you. Email me if you need any help or come on by.